Okay, in this video we will talk about the Q&A of this session. An electromagnetic coil of resistance 300 ohm and inductance 5 Henry is connected to an alternating voltage supply of amplitude 240 volt and frequency 60 Hz. Calculate the impedance of the coil. Impedance of the RCL-series circuit is like this. Then you substitute everything inside. Then you can get the impedance. Remember, the impedance and the reactance and the resistance has the same unit, which is ohm. Please calculate the root mean square current. V0 equal to I0 Z. The peak voltage of the supply is 240. And then Z is this. Then you can get the peak current. Once you get the peak current, you can also get the root mean square current. Sketch the phasor diagram. Okay, when you are sketching the phasor diagram, please label all the symbols that you use. And then we know that the voltage across the inductor will lead the voltage across the resistor and also current by 90 degrees. So this is the phasor diagram. A resistor of 2 ohm and an inductor of 5 mH connected in series to an alternating source are shown. So this is the supply. This is the voltage supply, this is the resistor, and this is the inductor. And then the current is like this, I equal to I0 sine omega t, where I is in amperes and t is in seconds. Please calculate the impedance of the RL series circuit. Then you can get the answer. Please determine the maximum voltage across the circuit. Maximum voltage of the source, which is equal to I0 times Z. And then the I0 is 1.5 ampere. Z is this one. Okay, so you can get the maximum voltage of the source. Okay, do you know why when the question asks us to give the maximum voltage across the circuit, then I give the maximum voltage of the source? Because this is the voltage of the source, and then this is what? This is voltage across the inductor. This is voltage across the resistor. Alright. So if this is 3 cm, this is 4 cm, then this is 5 cm. So of course, when I want to find the maximum voltage across the circuit, of course this is referring to the maximum voltage of the supply, not the maximum voltage across the L or the R. A coil of wire with inductance 0.125 Henry and resistance 25 ohm is connected to an alternating source of 120 volt and 50 Hz. Determine the impedance of the RL series circuit. Calculate the phase angle between the current and voltage. State whether the current leads or lags behind the voltage. Okay, you know that the voltage across the inductor must lead the current and also voltage across the resistor by 90 degrees. Okay, and then when you want to find the phase angle between the current and the voltage, which is here, the phase angle between the voltage and the current, this is the phase angle, and then you can use the formula like this. Tangent theta equal to VL over VR. Okay. So you substitute everything inside, VL equal to IXL, VR equal to IR. Then you can get the phase angle. Then you know that V leads I by how many degrees. A pure inductor and a pure resistor are connected in series with a sinusoidal voltage supply of maximum voltage 330 volt. If the maximum potential difference across the resistor is 200 volt, please find the maximum potential difference across the inductor. We know that the voltage of the inductor must lead the voltage across the resistor by 90 degrees. And then the voltage of the supply is like this. V squared equal to VL squared plus VR squared. If this is peak value, this is peak value, and this is peak value. If this is root mean square value, this is root mean square value, and this is also root mean square value. And now they are all referring to the maximum value. Okay, you substitute everything inside, then you can get the answer. An alternating voltage is given by this function where V is in millivolts. Remember, when they change the unit, that means that they are no longer using volts. You have to be careful of the magnitude. Okay, and then this voltage is applied across a pure capacitor. Please determine the root mean square voltage. Root mean square voltage equal to V0 over square root 2. What is V0? V0 is 340 times 10 power negative 3 volt. Okay, then you can get the root mean square voltage. Please derive the expression for the current which flows through the resistor. Then you use Q equal to CV. Then you differentiate V. Okay, when you differentiate this, then you can get the function for the I. Okay, then of course this is in ampere. Determine the reactance for the capacitor. The reactance for the capacitor is 1 over omega C. Okay, what is omega, please? Omega is 314. Omega is 314. A resistor is then connected in series to the capacitor so that the current is reduced. Determine the value of resistance of the resistor which must be connected in order for the root mean square current I be reduced to 2.4 milliampere. Root mean square value of the source voltage equal to IRMS times Z. What is the root mean square value of the source, please? 240 millivolt. 240 millivolt. IRMS is 2.4 milliampere. Then the Z must be 100 ohm, and then the Z for the RC series circuit is like this. Then you can know the value for R. Determine the phase angle between the current I and also the voltage V. Sketch the phasor diagram. Okay, when you are sketching the phasor diagram, you also have to label them. That means that I is the current, VR is the resistor voltage, V is the source voltage, VC is the capacitor voltage. Okay, but I'm lazy to label it here. Okay, and then you have to find out the phase angle. Tangent theta equal to this over this. Okay, then you know I leads V by how many angle. A power source with root mean square voltage 240 volt and frequency 50 Hz is connected in series to a capacitor of 3200 microfarad and a resistor of 5 ohm. Please determine the impedance of the RC series circuit. Okay, then calculate the root mean square potential difference across the capacitor. When you want to find the root mean square potential difference across the capacitor, you have to know the root mean square current first. So how do you know the root mean square current? In the question, they give us the root mean square voltage of the power source. Then therefore you can use this formula. Root mean square voltage of the source is equal to the root mean square current times the impedance. Then you can get the root mean square current. Then you substitute the value for the root mean square current here. Okay, root mean square voltage across the capacitor is equal to IRMS times the reactance of the capacitor. Then determine the phase difference between the current in the circuit and also the supply voltage V. Okay, so the angle you have to find out by using these formulas. Then you know that I leads V by this phase angle. A capacitor of capacitance 200 microfarad and a resistor of resistance 80 ohm are connected in series to an alternating supply of root mean square voltage 12 volt with a frequency of 50 Hz. Please calculate the root mean square current of the circuit. In order to find out the root mean square current of the circuit, you have to know the value of the impedance first. Then you find out the value for the impedance. And then you substitute into the formula, which is the root mean square voltage of the current supply equal to the root mean square current times the Z, which is the impedance. And then please calculate the root mean square voltage across the resistor and the root mean square voltage across the capacitor. In order to get the root mean square voltage across the resistor, you need to know the root mean square current and then times the R. This is equal to the root mean square voltage across the resistor. Then the root mean square voltage across the capacitor is equal to IRMS times the reactance of the capacitor. After getting these two answers, you can check whether 12 square is equal to 11.8 square plus 2.34 square. If the formula is correct, that means that if the answers fit the formula, then probably your answer is correct. And then you cannot straight away add them up. That means that 12 is not equal to 11.8 plus 2.34 because the VRMS of resistor and the VRMS of capacitor are not in phase. When they are in phase, then only you can straight away add them up, but they are not in phase. In fact, root mean square voltage of the resistor leads root mean square voltage of the capacitor by 90 degrees. Recall one question that you have done in the previous video. The bulb is a resistor, and then the bulb is connected in series with another resistor. That means that both of them are resistors. So you can straight away add them up because the root mean square of the bulb is in phase with the root mean square voltage of the resistor because they are both resistors. Therefore, you can straight away add them up. But then, now they are not in phase, therefore you have to use this formula because the phase angle is just 90 degrees. Then you can use the Pythagoras theorem. That is for right angle triangle. Okay? So, state the relationship between VR, VC and VS. VS square equal to VR square plus VC square. Okay? If they are in phase, then only you straight away add them up. If they are not, then you use a trigonometry method to add them up. A filament bulb labeled 100 volt, which is the root mean square voltage, and 40 watt, which is the mean power, is connected in series with a capacitor and sinusoidal voltage supply of root mean square voltage 240 volt and frequency 50 Hz. If the bulb lit with a normal brightness, please calculate the capacitance of the capacitor. Okay, from this, you know the root mean square voltage of the bulb, which is the resistor. From this, you know that the root mean square voltage of the supply, the current supply is 240 volt. Then by using this formula, you know the root mean square potential difference across the capacitor. Then at the same time, by providing you with the power and the root mean square voltage, you can get the root mean square current. Okay? Because they are connected in series, so once you find the root mean square current across the bulb, which is across the resistor, you straight away know that it is the same as the current that flows through the capacitor because they are connected in series. Okay, so after knowing these two terms, you can get the C by using this formula. The root mean square voltage across the capacitor equal to the root mean square current times the reactance of the capacitor. And then reactance of capacitor is what? 1 over omega C. And then please find the phase angle between the current and the voltage supply. Okay, you know that current is leading V by a phase angle. Okay, this is a RCL series circuit. This is the voltage supply. Please calculate the impedance. In calculating the impedance, you need to know the omega. V equal to V0 sine omega t. So omega equal to 100 pi. Okay, therefore this is our impedance. Please find the root mean square circuit current. Root mean square voltage of the source divided by root mean square circuit current equal to Z, because this is the definition for the Z impedance. Then you can get the root mean square current. After getting the root mean square current, you can find the root mean square voltage across the inductor, capacitor, and resistor respectively. Vrms across the inductor equal to Irms times the reactance of the inductor. For the capacitor is the root mean square current times the reactance of the capacitor. Then for the resistor is the Irms times the resistance. After getting those answers, you can check whether your answers are correct or not by using this formula. The voltage source is equal to this formula. That means that you substitute everything inside. See whether you can get the root mean square voltage of your supply or not. Just now in the question, you know the peak voltage of the supply. And then you divided it by square root 2. Then you know the root mean square voltage of the supply. So now they fit. So you know that most probably your answers are correct. Okay. So this is all in the chapter 18, alternating current circuits. Hopefully you can learn something from those videos. Thank you.